you'll notice that the final version of your module for assessment, it has been posted. There was a glitch of some sort with Blackboard, and it was supposed to be out there sooner. We've established a deadline by the end of the week, 11:59 p.m. Saturday, this Saturday. If you can, while the trail is fresh, if you can finish reconciliation, we covered item analysis in class on 7 November. The link is embedded in the reconciliation assignment. And if you can pivot quickly and get that taken care of, there'll be less to engage the last week of finals. We'll also be completing the scoring of solutions and assignments you've posted. So if you find that the credit you receive for a given assignment or solution is not to your standards and you'd like to post more, just take a note of the comments, go ahead and revise your assignment or solution and resubmit again. If you find that resubmission is blocked or it's not working, send me an email and we'll check the settings to make sure that things are. You're supposed to be able to submit twice or 3 times for the more involved assignments and solutions. And so this is just to bring Module 4 to a close. Module 5, you should find Module 5 on the screen now as you check back into the course. And it is a lighter, shorter, but more complex module. So there's more hands-on, there's less concepts and content, but there's more activities, instructional activities, right? So one of the things we'll be talking about are computer simulations and data mining. So it's kind of a special topics module. And one of the things that we want to do in just a moment is to talk about this idea of using graphics processors to work the simulations, because modern GPUs have the muscle of what used to be supercomputers just 10 years ago. This is an amazing progression. And when you think about it, being able to buy a graphics card for your gaming platform, right? So you have a gaming workstation or maybe a laptop, and that laptop has a dedicated graphics controller, an NVIDIA or an AMD. And you may or may not know this, but in the last 10 years, the GPUs, the graphics processing unit, has progressed dramatically according to Moore's law. And using OpenGL, you can perform teraflops of calculations, floating point calculations. So a flop is a floating point calculation, and teraflops are, I mean, it's a lot. It's like a terabyte, right? So you're looking at a giga, that's 1,000 megas. And when you look at a tera, it's 1,000 gigas. So that's an awful lot of computing power. And it's just a really interesting concept. There are now very simple ways to engage the GPU if you have one. And this is something that you should check on your own system to see whether or not you can take advantage of that. There's actually going to be an assignment associated with that, but it's not the first assignment, right? The first assignment in our, any questions at this point?
No.
Okay. So I keep talking about unexpected surprises in the Blackboard environment. As you view your Blackboard environment, are you seeing the same like rose colored motif?
The same what?
Do you have the same color motif on your Blackboard screen?
Oh, no, no, mine doesn't show that. I just get black or blue.
Okay. How about you, Tamara?
Can you repeat the question?
Well, when I'm in different courses, I have different color schemes, and I come into this module and now everything's rose colored. And
No, it doesn't do that for me.
doesn't. Okay. Yeah, there's little hiccups, little glitches here and there. I didn't set this to that color scheme. I'm not sure why it's showing up this way, but it is. So anyway, can everyone see the screen?
Yes.
All right, so you're going to watch and follow the steps in this 3-minute YouTube video. Now this is high speed, boom, 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 step by step, very fast. But of course, if it's a YouTube video, you can, slow it down. Everybody knows that YouTube, you can slow down YouTube, yeah? Were you aware you can slow it down?
Yeah.
So this is one of those cases where you might want to slow it down. If you were working a specific video.
I think part of it for me was the fact
After the, maybe this is not,
that it was self-paced.
I want to show this to you.
This is the first of 100 wells we're gonna build in this video.
So after the ad is cleared, the thing that I want to share with you is that you can slow down the playback speed to like 0.75 or half speed, 0.5. And that may be a good thing for this particular assignment because the steps hit very fast and furious, and what we don't want is folks getting frustrated and you get a few steps down the road and then your simulation doesn't work. What you'll do is generate some random numbers, and one of the things that we do for computer simulations is take advantage of sample data or random data. If you have very large amounts of data, it's impractical to analyze every one of those data elements. And so oftentimes there's sampling involved, or you extract the variable values with an algorithm so that it's completely randomly selected, right? And this is something that we'll go into much greater depth on Tuesday, but one of the points we're trying to make here is that you're going to use an Excel template. And that Excel template is going to provide you with the ability to generate random numbers. The more random, the purely, so algorithms have a bias, and depending on the computing algorithm that's used to generate random numbers, one thing that computer scientists have determined recently is that there is a pattern to that randomness. So therefore, it's not really purely random. That's one of the holy grails of mathematics, is to find a way to create quality random data. And so sometimes what they'll do is they'll take other data inputs and kind of as a salt in the algorithm. One example of this is fan noise. So they'll take your common cooling fan and they'll put a microphone next to a noisy cooling fan, and then they'll capture the audio data from the noisy cooling fan, and then they'll use the algorithm to generate the random data that's used for a simulation. And it's more random because there's natural variation in the fan noise and then in the algorithm. So that's just one thing they're trying to do to create quality random data sets, right? Large data sets that are suitable for simulations. So we told you GIGO, garbage in, garbage out. Does everybody remember that?
Yes.
Right. So if you have poor quality of data going in, you have less quality for the outcomes, the results. And so if you have a very high quality sampling of truly random data, then simulations tend to be more reliable. This is just, again, one thing we'll cover in greater depth. What I want you to do is to get a heads up and get started with the Monte Carlo simulation. So that's based on a Monte Carlo model. And so this video basically walks through the steps that you would follow to execute the Monte Carlo method to predict market outcomes, right? So I think it was a financial market they were talking about. And that's, of course, that's really useful. If you can predict financial market outcomes before they actually happen, then that would be an advantage for some if you invest lots of money. I'm just saying. Along similar lines, if you are working computer simulations for scientific purposes, you know, the same principles apply. Good afternoon. How are you, Amari?
Good afternoon, Professor.
You ready for the long weekend?
You already know
The extended holiday weekend, yes. So we're talking about Module 5. We did post the retake in Module 4, but we're talking about the first assignment in Module 5, where you will use Excel and you'll follow these steps. It's a short video. It walks through the procedure very fast. So I just recommended that you use the slow down option in YouTube. So you might want to check the recording before you join just to see what that's all about, okay?
Okay.
Yeah, we just want to cut down on the amount of frustration. The second assignment, so this is, even though this is an assignment, it's worth 5 points. So we could almost call this the 5.1 solution instead of assignment. So don't be fooled by the fact that this is described as an assignment, right? It's shorter, takes less time to complete, I think. So, but it's still an important amount of credit for your grade in the final module. The second instructional activity that you'll engage in Module 5 is our solution, and what you're going to do is you'll take some baby steps in the data mining arena. So you'll have a series of SQL statements, and so you'll execute those SQL statements, and then the output of those SQL statements will be fed into still more SQL statements. So it's kind of a chain link or chaining effect. So you'll run SQL against SQL. You'll run SQL statements against other SQL output, and it's iterative. So essentially what we'll be doing is some data mining to get more information out of a group of data sets that would otherwise kind of look pretty bland and pretty plain. And that's the important part to understand, is that you can visually inspect data sets, and they don't have to be very large, and they may be related in very basic ways, but the outcomes that the conclusions you can draw reliably from structured data with complex SQL algorithms, right? You can mine that data and have confidence in the conclusions of that data. We will include a third assignment that involves GPUs. So we started a little while ago by explaining this is a 50-page PDF, but there's some really cool stuff in here. And what we wanted to do was to just share the basic information. And it's produced by NVIDIA. So you can actually search for this online. This came out in 2009, so that gives you an idea of how the use of graphical processors, right? Video gaming cards would take on a life of its own. So it's not just in gaming platforms, but if you take the same graphics processors that are in the gaming video cards and you use OpenGL, you can perform nowadays, if we fast forward between 2009 and we look at what graphics controllers can do nowadays in 2023, let's just check the dipstick on that. That would be kind of fun to do for a moment. So NVIDIA, yeah. So this is a common 3070. This is not an expensive video card. Is anyone familiar with NVIDIA as a brand?
Yes, it's a GPU unit.
Right. So if you look at this thing, let's see if I can open this link in a new tab. This is the kind of graphics controller card. So you'd put this in a gaming PC. And it's under $1,000, it's under $1,000, I think. So if we look at cost, yeah, it's well under $1,000. Okay. So if you look at now that these are laboratory, so NVIDIA makes a card called the Titan RTX. It's oh my gosh, it's huge as far as the computing capacity. Essentially, this thing is designed for research laboratories, so you'd have multiples of these in a box. But you don't have to spend $2,500 for each card and then put 4 of those in a workstation, so you've spent $10,000 on graphics controllers. But if you did, you'd have something that would match the supercomputing capacity of a Cray supercomputer just a few decades ago. And that's pretty amazing when you think about it. If we're looking at the 3070, you pick that up for $600 a piece, you could have 2 of those, a pair of those, and you could double the amount of teraflops. So this thing will perform 21 teraflops in terms of calculations. That's in terms of floating point calculations, numbers with decimal points. That's a huge amount. So if you had a pair of those for $1,200, that's it's 42 and change, 43 teraflops. And the whole point of that is you can use it to render very complex graphical representations of data sets. And that's one of the advantages, but you can also use it just for raw calculations. So now that They're still building supercomputers that cost millions and millions of dollars. But since 1992, and then but back in the day, you could not purchase these kinds of cards for $600. It was more like $2,000, and they were not nearly as capable, right? So there's additional information here on the applications and coding interests. It's mostly for your reference, but we'll be calling out the specific points of interest in the study guide. I just thought it would be good to point that out. That's in the references folder in Blackboard. Any questions so far?
No, no questions.
You'll have a chance to log into a system that has a card like this. And what you'll be able to do is to assign the GPU as the primary processor to run the application. So why would you care? Let's say that you're working some video and graphics rendering for anything. Could be a media project, it could be something you're doing for TikTok, but more to the point, it could be some really cool stuff with lasers and optical interests for research. Essentially, you can take the software that you'd use to work with that data, and you would assign the application to use the GPU exclusively, or more so for the work you're doing, and it would take far less time to render that output. So that's going to be part of the third assignment. We will also engage some new interests called NoSQL. So when we talk about much of the data that we have to work with, especially big data sets out on that are open source out on the internet, they're not neatly organized into data tables. It's not structured. So when you have unstructured data to work with, and you need to be able to use that unstructured data, and there's a lot of it, a SQL database is not the best method or tool to approach that challenge. And so we do have a data science minor, I believe, and a data science concentration in some of our degree programs. And so we'll be touching on some aspects of data science in the NoSQL arena, and that will be part of the third assignment. So you'll work with GPU capabilities, and we'll ask you to take some quick steps to work some NoSQL activities, take it for a spin around the block. Does anyone have any questions about what we're planning for our final module in the course?
No questions.
One thing I'd like to add is that this component of our course is completely new content. So it's new material that others before you who have enrolled in CSC239, they did not have access to platforms to work this kind of cool stuff. And I'm really excited about offering this these fresh ideas as a final topic in the course. So in any case, that's coming soon to a screen near you. We are going to develop the student learning modules a little further, but the primary topics are here. And we do have the first two learning outcomes cleanly stated. You know, explain how modeling differs from statistical analysis, and describe 2 common adaptions when you're dealing with data sampling in NoSQL, right? So any questions before we clear? We'd like you to complete the first assignment for the Monte Carlo simulation by the start of class 3 p.m. on Tuesday. And if you can, between now and then, polish off the final attempt of the Module 4 assessment after you finish reconciliation. Questions, comments?
No questions.
And that's all we had planned for today. Enjoy the extended holiday weekend. Hope it's pleasant and safe, and we'll see you on Tuesday at 3 p.m.
You too.
14 November. Take care.